Humans possess the natural ability to maintain body orientation and posture in relation to their surrounding environment, whether at rest or motion. Good spatial orientation is due to effective perception and interpretation of your senses: visual, vestibular, proprioceptive, and auditory information. Two modules will be used to discuss how your body maintains spatial orientation. This module will focus on the vestibular and proprioceptive systems. The second module will discuss the visual system. Under certain conditions, your flight environment can create sensory conflicts and illusions that make orientation difficult and, in some cases, impossible to achieve. Spatial disorientation is the loss of your orientation in relation to the Earth's surface, caused mainly by a lack of and/or misinterpretation of visual, vestibular, or proprioceptive sensory inputs to the brain. Spatial orientation during flight requires an understanding of your sensory organs and knowing how you can compensate for their limitations. Visual references provide the dominant sensory information to maintain spatial orientation. This is especially true when your body and/or environment are in motion. Changes in linear, angular, or gravitational acceleration are detected by the vestibular system. Information gathered is mentally compared to the visual information being received. When flying your aircraft in instrument conditions, without outside visual information available, the aircraft flight instruments are the only means to confirm your aircraft position. Under these conditions, vestibular system can give false illusions. The vestibular system is located in the inner ear. This system is the size of a pencil eraser and contains two distinct structures: the semicircular canals and the otolith organs. The semicircular canals detect changes in angular acceleration, while the otolith organs detect changes in linear acceleration. Both of these provide information regarding your body's position and movement relative to Earth. Three half-circular interconnected tubes inside each ear comprise the semicircular canals. The semicircular canals of both inner ears monitor angular acceleration and sense rotation in 3 dimensions. The planes of the 3 canals in each ear correspond to the roll, pitch, or yaw motions of an aircraft. Each canal is filled with a thick fluid and contains hair cells. The hair cells move as the fluid moves inside the canal. The fluid moves in response to angular acceleration. The movement of the hair cells is similar to the movement of seaweed caused by ocean current. If your head is kept still and the airplane is flying straight and level, the fluid in the canals will not move and the hair cells will remain erect. This signals your brain that there is no rotational acceleration and can be confirmed either visually or by instruments. The somatogyral illusions concerns false sensations about the magnitude and/or false perception of rotation in its actual absence. The graveyard spiral and spin due to somatogyral illusions are 2 of the oldest in aviation. The semicircular canal is activated when you accelerate rapidly into a turn, in this case a left turn. The fluid within the semicircular canal lags behind the accelerated canal walls and bends the hair cells to the right, or in the direction opposite that of the imposed acceleration. The brain interprets the movement of the hair cells to the right as angular movement to the left. If the turn continues at a constant rate for several seconds or longer, the motion of fluid catches up with the canal walls. The hair cells are no longer bent, and the brain receives the completely false impression that turning has stopped. When you return to level flight, the fluid inside the canal will continue to move during the rollout and even for a while after the turn stops. This will send a signal to the brain indicating that you are turning in the opposite direction, an illusion. You can observe this reaction by using a Barony chair to simulate a constant rate turn. Blindfold or place goggles on a pilot to deprive the subject of visual cues and secure them in the Barony chair. The subject is then told to indicate the rotation of turn by using thumb signals. As the rotation begins, the subject is aware of the movement. But will gradually lose the turning sensation as the fluid catches up to the rotation. As the chair is brought to a sudden stop, the canal fluid continues to move for a short period of time and the hair cells are bent to the left. This gives the subject the illusion of turning opposite the original direction. If this sensory illusion is believed, you may try to counteract it by inappropriately turning the aircraft in the original direction. Now, let's examine some other in-flight illusions that are caused by the semicircular canals. The leans is the most common sensory illusion related to stimulation of the semicircular canals. The leans can be caused by two different circumstances while flying instruments without outside references. Remember this: it is possible for you to be unaware of a gradual turn of the aircraft because human exposure to a rotational acceleration of 2 degrees per second squared or less is below the detection threshold of the semicircular canals. The first scenario is when the aircraft tips to one side quickly enough for you to detect the movement, and you smoothly return the aircraft to straight and level below the detection threshold of the semicircular canals. You may sense the aircraft is still tilted to that side. The sensation will be so convincing that you will actually lean away from the perceived tilting even though the instruments read straight and level. The opposite may occur, causing the second scenario. You become aware of a gradual or prolonged turn of the aircraft that went unnoticed and take abrupt corrective action to level the aircraft. The illusion of banking in the opposite direction can occur, and you may lean in order to align yourself with the supposed axis of the aircraft. In both cases, trust your attitude indicator. Maintain aircraft control even though you retain the false perception of bank. The Coriolis illusion is probably the most dangerous of the vestibular illusions. This illusion involves the simultaneous stimulation of 2 or more semicircular canals in each ear, as is associated with a sudden tilting of your head, forward or backwards or to the side, while the aircraft is turning. This can occur when you tilt your head down to look at an approach chart or to write a note on your knee pad, or tilt it up to look at an overhead instrument or switch. This produces a very incapacitating sensation that the aircraft is rolling, pitching, and yawing all at the same time. This very uncomfortable illusion can make you become airsick or may result in losing control of the aircraft. To prevent this reaction, avoid sudden extreme head movements while making turns. The otolith organs are located in each ear at the base of the semicircular canals. The otoliths detect changes in linear acceleration in the horizontal plane and changes in the position of the head in relation to gravitational forces. Their structure consists of small sacs covered by hair cell filaments. These filaments project into an overlying gelatinous membrane tipped by tiny calcium stones. Let's observe this organ and how it operates. The sensory hairs will deflect with a change in your head position due to gravity acting upon them. So when you tilt your head, the resting frequency is altered and the brain is informed of your new head position in relation to the vertical plane. The biggest problem occurs when there is exposure to linear acceleration, such as during takeoff or landing. During takeoff, with sufficient forward linear acceleration, the fluid will flow over the otoliths and send a signal to the brain, inducing a false sensation of over-rotation. This illusion would tell you to push forward with the controls regardless of aircraft attitude. This would cause the aircraft to nose over and possibly crash. Another sensory input that plays a role in maintaining spatial orientation comes from the proprioceptors located in the skin, muscles, tendons, and joints. Proprioceptors provide information about body position and movements. By sensing points of physical contact between body parts and the surrounding environment, the proprioceptors make it possible for you to know your relative posture. These sensations provide the seat-of-the-pants sense, often referred to in flying. However, they alone will not let you differentiate between flying straight and level and performing a coordinated turn. Hearing does not create any significant role in illusions and plays a minor role in spatial orientation. The visual and vestibular systems play a dominant role in spatial orientation and override the small inputs of the proprioceptive and auditory systems. The best way to protect against spatial disorientation is to educate yourself about the sensory illusions and recognize your limits as a pilot. Take the opportunity to personally experience sensory illusions in a Barony chair, a gyro, or a virtual reality spatial disorientation demonstrator. By experiencing sensory illusions firsthand, on the ground, pilots are better prepared to recognize a sensory illusion when it happens during flight. The Aeromedical Education Division of the FAA Civil Aeromedical Institute offers spatial disorientation demonstrations with the gyro and the virtual reality spatial disorientation demonstrator in Oklahoma City. CAMI also makes these machines available at major air shows in the continental United States. Spatial disorientation is a killer. By following a few precautions, you can prevent or cope with this problem of disorientation. Obtain a thorough weather briefing. Correct interpretation of the briefing. The benefit of 180-degree turn before entering IFR conditions. If you find yourself in instrument conditions, concentrate on flying basic instruments and disregard your body's sensations. Concentrate on your instruments. Remove yourself from the peripheral vision environment and its cues and distractions. Increase instrument cross-check rate. Ask ATC for help as soon as you recognize a problem. While under instrument conditions, avoid head movements during turns. Use your eyes rather than your head. Defer non-essential tasks. Concentrate on flying the aircraft. If you are one of two pilots in an aircraft and you begin to experience a sensory illusion, transfer control of the aircraft to the other pilot. It is seldom that pilots experience sensory illusions at the same time. If an autopilot is available, use it until the sensory illusion dissipates. By being knowledgeable, relying on experience, and trusting your instruments, you will be contributing to keeping the skies safe for everyone. Spatial disorientation is the loss of your orientation in relation to the Earth's surface, caused mainly by a lack of and/or misinterpretation of visual, vestibular, or proprioceptive sensory inputs to the brain. Visual references provide the dominant sensory information to maintain spatial orientation. Changes in linear, angular, or gravitational acceleration are detected by the vestibular system. The inner ear contains the vestibular system. This system is the size of a pencil eraser and contains two distinct structures, the semicircular canals and the otolith organs. The semicircular canals of both inner ears monitor angular acceleration and sense rotation in 3 dimensions. The planes of the 3 canals in each ear correspond to the roll, pitch, or yaw motions of an aircraft. The somatogyral illusions concerns false sensations about the magnitude and/or false perception of rotation in its actual absence. The graveyard spiral and spin, due to somatogyral illusions, are 2 of the oldest in aviation. The leans is the most common sensory illusion related to stimulation of the semicircular canals. The Coriolis illusion involves the simultaneous stimulation of 2 or more semicircular canals in each ear and is associated with a sudden tilting of your head forward or backwards or to the side while the aircraft is turning. The otoliths detect changes in linear acceleration in the horizontal plane and changes in the position of the head in relation to gravitational forces. Another sensory input that plays a role in maintaining spatial orientation comes from the proprioceptors located in the skin, muscles, tendons, and joints. Proprioceptors provide information about body position and movements. Hearing does not create any significant role in illusions and plays a minor role in spatial orientation. The dominant role that the visual and vestibular systems play in spatial orientation override the small inputs of the proprioceptive and auditory systems. The best way to protect against spatial disorientation is to educate yourself about sensory illusions, recognize your limits as a pilot, obtain a pilot instrument rating, stay current, trust your instruments. Spatial disorientation is a killer. By being knowledgeable and trusting your instruments, you'll be contributing to keeping the skies safe for everyone.